So Google has made a new quantum computer named Willow, which can do a special kind of calculation in just 5 minutes, which would take around 700 trillion times more time than the age of the universe for the fastest supercomputers in the world to calculate. But how is this possible? In the previous video of this series, we saw how computers evolved from this 2,000-year-old mechanical device using microprocessors made of billions of transistors. We also saw how technology evolved in various ways, how we exploited scientific laws, and where this journey has brought us so far. In the dawn of a new era, the quantum age, this is the story of the year 1981. In a lecture at the Massachusetts Institute of Technology called Simulating Physics with Computers, a very intelligent scientist, Richard Feynman, made an observation about quantum systems like atoms, molecules, and particles. Work on the principles of quantum mechanics, and these quantum behaviors are so complicated that they cannot be understood by the straightforward ones and zeros of binary logic of classical computers. For understanding them, we would need such a computer that works only on the quantum laws. His statement became very famous too. Nature is not classical, damn it. If you want to create a simulation of the nature, you better make it quantum mechanical. In fact, Feynman has proposed some beautiful ideas which will pave the way for the creation of quantum computers in the future. Just like he suggested that today we use transistors as an on-off switch in binary language, on being 1, off being 0, and we create logical operations from these combinations exactly. Similarly, we can use the spin of electrons in quantum computers, spin up being 1 and spin down being 0. But what maximum will be possible to assign electrons to up or down, spin or 1 or 0? Even if a little computer becomes powerful, where will the unimaginable power finally come from in the quantum computer? Well, quantum mechanics, or rather, the world of subatomic particles, gets its immense power from two very powerful phenomena. Number 1, quantum superposition, and number 2, quantum entanglement. To understand how these powerful principles are used in quantum computers today, let's take a look at a very important experiment in quantum mechanics, the double slit experiment. Now pay attention, because many people feel that they have understood this experiment very well, but often they are wrong, and without understanding this experiment, you won't be able to fully understand quantum computers, so pay attention. Imagine you have a straight plate with 2 parallel slits on it. And if you fire some grains of sand at the plate, what kind of pattern would you see on a screen placed behind the plate? Well, 2 parallel lines, right? This is common sense, but what isn't common sense is that if you now fire subatomic particles like electrons or photons instead of sand, you won't see this pattern on the screen on the other side. Instead, you will see a different pattern. Now, what is this thing? Why is it happening like this? Well, we call this pattern an interference pattern, and this pattern is created by waves because, unlike particles, the behavior of waves is such that they interact with themselves, they interfere. So are subatomic particles not particles, but actual waves? Weren't we taught that they are particles? Well, yes, they are particles, but they behave like waves. Their movement in our world is like a wave, and that's why we talk about wave-particle duality, showing these two aspects of particles. Now, when they were fired together on 2 slits, it became a mystery whether they came out as a single wave through both slits or as a single particle quantity, even though they passed through 2 slits. This property of these particles is called superposition. They can be present at 2 places at the same time. Now, this thing is a bit challenging for our common sense. But keep going, we will start to make a little bit of sense. Now, imagine using this superposition principle in some way. We can combine it with multiple combinations of calculations. And if we could use it for computing, well, this was the first idea that came to David Deutsch, the father of quantum computer in the 1980s, who then started working on this idea. Now let's move on to our experiment. So now tell me, what happens if a wave passes through 2 slits? Well, it will break down as it passes through those 2 slits. In multiple waves, they will interact with each other and create interference. Now, there are 2 types of interference. constructive interference and destructive interference. If in one interference, two waves of the same size and structure combine, then it is called constructive interference. And in this case, since they are combining, due to the addition, the size of that wave will increase. And if, let's say, due to interference, if two waves are canceling each other out, then this is called destructive interference. And in that case, those waves will either decrease or totally cancel out. Now pay attention to the slide at the back. Wherever you see these bright stripes, those are all the areas where constructive interference has occurred, meaning their waves have converged, amplified, and as a result, more particles have accumulated there. Now, friends, I'm going to hold here for a few seconds to think a little and tell me what we learned from this. Well, the first thing is that you can't exactly pinpoint a particle where it will be found. But can you definitely estimate where it has the highest chances of being found? The second thing, you can also predict where the chances of not finding that particle are high. This is only due to the wave behavior of that particle, and wave behavior is not deterministic but probabilistic. This means that you can't say with 100% certainty where those particles will be found, but you can use the maths of probability to make the best guess where those particles might be found. And the bright areas you see on the slide are the highly probable areas where you can find a fired particle at any given time. The brighter and larger the area, the higher the probability of finding a particle there. Since the time we realized this, we understood that the quantum world is not based on fixed outcomes, but rather on probabilities. We no longer saw the world as chaotic, and we began to understand it, creating our own rules. Like in 1926, a German physicist, Max Born, created his own formula, which could exactly predict the probability of a particle being in a certain place. We were making the uncertainty itself certain. And these observations played a major role in the creation of quantum computers and algorithms. Look, in the double slit experiment, what did the particles basically show? That they could take multiple paths at once. And finally, we could tell where the chances of finding them were highest. Can't this principle be used in a computer to solve a problem where there are millions of options, but the correct answer is just one or a few? Like breaking the encryption code of some high security data. Well, in principle, if we break this down, to build a quantum computer, our goal will basically be just to use the probability and interference effects of quantum mechanics correctly and combine similar waves and their probabilities repeatedly. And after some processing, we can get close to our answer, like we saw in the double slit experiment that those waves were telling by interacting in a very particular way where that particle can land. In the same way, we can mail waves interfere in quantum computers, and we can suppress all those destructive or average wave patterns and focus on those particular most constructive interference patterns, which will amplify the correct answer to come to our attention. So basically, we can literally build the correct answer from our quantum processing through the interference of millions of waves. All we need for this is some special algorithms in that computer to mathematically direct this process. And this is the fundamental principle behind quantum computers. To eliminate the destructive interference and regular waves, to eliminate the noise, the waves that are combining and interfering constructively, let them combine like in music where all coherent waves are in sync and the correct answer will most certainly be there. Now let's understand this principle in working with an example. First with a bit of common sense, then with the correct interpretation of quantum mechanics. But before understanding that, with the increase in technology, there has been a lot of development in cosmetic science as well. Today, such advanced skincare formulations are available, which can scientifically reverse aging science like wrinkles, dark spots, skin dullness. Actually, in Indians, skin damages quite a lot because of skin oxidation. You must have noticed. Even when you leave a piece of apple open for a while, it turns brown in a few moments. In the same way, our skin also becomes dark and dull from roaming in the sun all day. But on the other hand, if you apply vitamin C on an apple piece, you will see its oxidation slows down significantly. And that's why using vitamin C serums can be very effective, improving skin pigmentation and toning, slowing down skin aging. Now, testing the efficiency and stability of vitamin C is a very interesting test, betadine solution test. The science behind this is such that the serum with high-quality, stable vitamin C or ascorbic acid will reduce the iodine found in betadine, making the solution colorless. In this, if you see, Deconstruct's vitamin C serum is such a serum that easily passes this test, which means this serum is very stable and beginner-friendly. Also, it has ferulic acid to keep you sun protected, and therefore, you should definitely check this out. I will add the link of this product in the description below. Now let's move back to our video. So first of all, let me clear the basics that in a normal classical computer, classical bits are used for digital information transfer, which are basically silicon transistors. As we learned in the last video, these transistors switching on or off transmits information in the form of 0 or 1. All the programs, words, images, whatever you see on a computer screen are made up of these very ones and zeros. And the most important thing about these classical bits is that at one time, they will either denote 1 or 0, okay? So now let's talk about quantum computers. Well, they use very special kinds of bits to transfer information called qubits. Whether these qubits will be 1 or 0 depends on their particle spin, upspin, which is 1, or downspin, which is 0. Now, since qubits have a very special property called superposition, because of this, they can show both states equally at the same time. For example, if you toss a coin until the coin falls down, it will not reveal its state. And it can be mathematically written as an average of both heads and tails. In the same way, in the case of a qubit, until the qubit is not measured, it can exist in both states at the same time, binary 1 and 0. Now, I am going to show you a glimpse of the real power of a qubit. Imagine there is a complicated problem, like a rat maze, where there are hundreds of paths to move forward, but only one path leads out of the maze. Now, for a traditional computer to solve such a problem, the computer would have to go to the end of each path to find out which path actually leads out. But in the case of qubits, remember, they can exist in both states at once, meaning state 1 and 0, when a classical bit can only exist in one state, and for this reason, a qubit can simultaneously traverse on two paths and determine at the same time where these paths lead to. This is referred to as parallelism in the language of quantum computing, but the magic only starts here. If you slightly increase the number of qubits, you will understand its real power, because the processing power does not increase linearly but exponentially. Now look at the case of 2 bits. They can exist together in 2 to the power of 2, that is 4 states. Like state 1, the combination of 1, 1, state 2, the combination of 1, 0, state 3, the combination of 0, 1, state 4, the combination of 0, 0. Once again, they can exist at the same time in all states. This means that they can travel 4 paths in a maze at the same time. In the case of 3 qubits, they can travel 2 to the power of 3. That is 8 paths at the same time. And as it grows, if a simple quantum processor of 100 qubits is made, then how many paths will it process together? Just imagine 2 to the power of 100, that is so many paths, which is 1.26 nonillion, that is a number bigger than the total number of atoms in the entire observable universe. And in your maze, there were only 100 possible paths, even if there were 1 billion possible paths. This processor can solve it in milliseconds, and Google's this new processor only took 5 minutes. What today's other supercomputers would take 10 septillion years to do, but it doesn't stop over here. First, let me talk about the principle of quantum entanglement in quantum computers. I will also make it clear that the maze example we took is a bit simplified to understand what is actually happening. Qubits, when combined, are literally transmitting millions and billions of waves in every direction, and the quantum computer is tracking their interferences. And finally, the computer separates the destructive interferences and decodes the constructive interferences to find the correct answer. Meaning, on the location where most of the waves are coherently matching, that is the correct answer. Because in the world of quantum physics, ultimately, the universe always prefers the shortest path to reach any destination. And because of this, most of the waves after interferences eventually lead to the right answer. This observation was also noticed by Richard Feynman, that there can be infinite possible paths from point A to point B. But a particle has this unique tendency that, probabilistically speaking, it will most certainly travel the shortest path. And Feynman mathematically proved this, developing what is known as Feynman's path integrals. Now, this is such a fundamental principle, and this only governs our entire universe. And so far, no theory has been able to contradict it, not even relativity or quantum mechanics. So now, friends, where have we reached? Well, we have an idea of how quantum computers use superposition for parallel computing. Now, we understand how these computers use another powerful principle, quantum entanglement. Okay, by the way, I will also discuss, I have put proper links in the references below, so you can also research on your own if you want. Through my two channels, Get Set Fly Science and Gaurav Thakur, my mission is to develop a scientific mindset among Indians and bring change at the root level of India. Now, we are expanding our team and we are looking for like-minded warriors. So if you like our creative editing and you can add value to our mission by joining our team of passionate creative editors, then your passion can become a thriving profession. We are looking for professional video editors for a work from office opportunity in Mumbai. Who can edit our documentary explainer type videos? More details down in the description below. Let's create an impact together, and now let's continue our video. If I say in a nutshell, quantum entanglement is basically a phenomenon where two or more qubits become linked, become entangled, which you can think of as being magically connected to each other and are able to share information no matter the difference or distance between them, no matter how much. Think of it as if one top is spinning left to right and it becomes entangled with another top, then both tops will spin left to right together. Imagine it as if they are linked to each other through some magical thread. This only occurs with quantum particles. The spinning tops were merely an example. But in the case of these quantum particles, it doesn't matter whether one particle is on Earth or even at the edge of another universe. They will remain connected to each other. Plus, the communication between the two is almost instantaneous, which can be very useful for signaling between systems. It's important to note that classical information cannot be transferred this way due to the limits of special relativity. So this principle basically allows a group of qubits to work together as a team, which can perform calculations parallelly and extremely fast. Now, after understanding the fundamental principles of quantum computers, everything makes sense, right, boss? These computers can be so powerful. We've seen it. So what else to do? Just distribute them to everyone's home, install them. This will help us work a bit faster, right? How much fun will it be to play those real-world feel games in these computers? Well, I really want to bust two very important misconceptions. First of all, these quantum computers, as you saw, are made to solve some different kind of problems. They are not made to run your PC, type Word, Excel, or then player-unknown battlegrounds problems. They are to find solutions for problems like a lock having billions of keys. But we have to find the right key, that too fast. We have to find the factorials of numbers having 200 digits, that too fast. Where we have to find some interesting patterns in extreme amounts of data, or we have to simulate quantum worlds, atoms, and molecules so that we can understand their properties. Those problems where extreme parallelism is needed, and these all problems usually are not common like yours and mine. So far, quantum algorithms have not been so advanced that they can perform all the general activities of a computer's operating system. Today, a quantum algorithm is made to solve very specific chosen problems, and we are slowly increasing the capacity of these algorithms and machines. Another thing is that we will also install quantum computers in our homes. When we learn to control quantum processes even at room temperatures, the fact is that even today, we do not know how nature converts light and carbon dioxide into sugar at room temperatures in plants and trees. Photosynthesis is a quantum phenomenon, which we still do not know exactly how it happens at room temperatures, because so far we have only been able to perform quantum interactions at extremely low temperatures of minus 273 degrees Celsius. Looking at this, it's more of a quantum computer, but in reality, this quantum computer is more like a fridge. This is called an inner dilution refrigerator. The quantum chip is just a small part at the base of this refrigerator. As you can see, in this refrigerator, these big pipes that you see, they pump helium or nitrogen down to the lower floors. Then, can you see these curled wires? They pass through, the signals pass in the form of microwaves, and finally, they are relayed to a classical computer. When this computer is running, it is placed inside a large cylinder-like enclosure, which is called an outer dilution refrigerator, to protect the processor from external temperature variations, heat, and electromagnetic radiation. Because the biggest problem with quantum processors is quantum decoherence, which means that external interference comes into their waves and their wave nature itself collapses. I have already made a detailed video on quantum decoherence, which will explain this concept to you in great depth. But basically, you should know the fact that quantum particles behave in a very strange way. But as soon as they interact with another particle or energy, their waveform collapses, and they become one particle from the wave of other possibilities, meaning that they lose their quantum properties such as superposition and quantum entanglement, and they are of no use to us. In the case of qubits too, the same thing happens. As soon as they come into interaction with anything, they immediately lose their quantum state, collapse, and this is called decoherence. To avoid this decoherence, quantum processors are kept extremely close to absolute zero temperature, which is the lowest temperature ever possible in the universe, because this state is literally the absence of any type of unnecessary motion and heat. These pipes you see are part of the entire cooling system, which maintains the absolute zero temperature. But even after this, it's not foolproof. You will not be surprised to hear this. But even after all this, the qubits remain active only for a few microseconds, and then they decohere immediately. The short time frame in which that qubit remains in superposition or coherence is known as coherence time, and this is a big challenge. In the path of making quantum computers a reality, many big companies are stumbling over these quantum computers. And exactly on this, Google's Willow chip has shown a very big achievement, has shown a leap.
Quantum computers is the wild card. It could be a game changer. It could change the entire landscape of artificial intelligence.
Google's Willow chip is touted as not just another technology breakthrough, but an evolution in under 5 minutes. The chip can solve a problem that would take today's most powerful computers 10 septillion years.
Google's Willow has left all superconducting quantum computers behind and has increased the coherence time by 5 times, and even then its coherence time is just a few microseconds. That is just 0.1 milliseconds. A qubit remains active only for 0.1 milliseconds and does its calculations. What will it do in such a short time? If you have seen your news headlines, then Google itself has claimed in these headlines that their computers have shown calculation for 5 minutes. So if their one qubit collapses in just 100 microseconds, then how can calculations run up to 5 minutes? Well, with the help of a special technique, which is literally the spine of quantum computing, quantum error correction. From this technique, quantum computers literally correct errors or decoherent qubits one by one and keep moving the processed information forward so that the show keeps going. Think of it basically like a relay race. Each qubit collapses in a fraction of a second after performing calculations in small parts. And it transfers its information to the other qubits like a relay, and then that qubit also keeps doing the same. So if a qubit's coherence time is 100 microseconds, its error correction should be at least 10 microseconds, so that the information keeps moving forward. Now, how does this error correction happen in real time? $1,000,000 question, right? Because according to the laws of quantum mechanics, if you physically interact with your qubits in any way, even touch them or measure them, they will immediately collapse their quantum state. So how is it possible that computers are able to fix the error without breaking the quantum state? Well, this problem is at the heart of quantum computing, how exactly it is fixed. To understand this, first understand that there are two types of errors in quantum computers. Number one, bit flip error, i.e., the information of the bit changes. 1 has become 0 or 0 has become 1. The second type of error is phase flip error, i.e., the dynamics of the system of entangled particles changes, such as, for example, 0 becomes +1 or -1. The probabilities remain 1 and 0, i.e., 50-50, but if a minus comes before 1, it will interact differently with other entangled particles, which can mess up the calculations. Now, how are these two types of errors fixed? To understand this, imagine you are building a sandcastle that is immediately eroded by wind and water, so you will have to protect it from the wind and water. How long can you keep it secure? We have the same problem with our qubit. It can't interact with anyone either, even by mistake. But now, if you make 3 exact replicas of your sandcastle, if one sandcastle gets hit by air or water and gets destroyed, then you will have other replicas at your disposal to fix that damaged sandcastle. Well, in quantum error correction, this popular technique that is called redundancy is used. In this technique, basically, a single information carrying logical qubit is encoded into 3 physical qubits, meaning that a logical qubit carrying information is now distributed among 3 physical qubits. Its basic equation will be like this. Instead of 0 plus 1, we will write this information as 1 logical qubit is equal to 0, 0, 0 plus 1, 1, 1. We will store it in this form. Now, if let's say 1 bit flips from 0 to 1, then the equation will become logical qubit is equal to 1, 0, 0 plus 1, 1, 1. Now, to rectify this mistake here, some helper qubits, or what are called ancillary qubits, will be deployed through quantum gates, which will precisely entangle with the errors. Just like there are logic gates in quantum circuits, which logically direct the flow of electrons, similarly, quantum logic gates logically direct the wave motion of quantum particles. To understand, here, those extra helper qubits themselves can interact with the error qubits easily with the quantum particles. And then if we measure those helper qubits, they will collapse and will tell us the exact type and location of the error. But the beauty of this technique is that it keeps the entire logical quantum system intact. Because we did not touch them, we only touched the helper qubits with the error qubits, made them interact and only measured those helper qubits. And then after exactly identifying the error, they can be flipped through logic gates if necessary, and this calculation will continue. This whole process can be finished within 10 microseconds. Now, if we talk about phase flip error, in this case, we make 3 physical qubits of 0, 0, 0 plus 1, 1, 1 and make 3 copies. It will be encoded in this form, plus, 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 minus, minus, minus. And in this also, helper qubits scan the entire quantum state and see the mismatch. If a mismatch is found, then identify that mismatch by syndrome measurement or wrong measurement, extract the code of the measurement, and apply quantum logic gates to fix it. Peter Shor created Shor's code, a popular algorithm that can protect from both bit flip and phase flip errors and can perform complex numerical calculations by using quantum logic gates, such as factoring large numbers. So basically, in quantum computers, qubits are quantum entangled to create many replicas of it. And when any qubit decoheres, it is reconstructed from the group of decohered qubits through some special algorithms, and then the qubit is manipulated in a certain way. And in this way, information is not lost, but rather, calculations continue to be extracted from the other entangled qubits, like a relay race. In the same way, Willow from Google has also achieved a breakthrough result in its quantum error correction code, where they have managed to reduce the error rate along with increasing the arrays of qubits. But even then, quantum computers of companies like Google, IBM, Xanadu, Honeywell, etc., are still very far from being able to solve real-life problems and computations. These are the three big problems. Number one is the stability of the quantum state. Number two is effective algorithms. And number three is real-time error corrections. Improving these effectively and economically scaling them are the biggest challenges. And if we can overcome these challenges, our future can completely change. Well, the doors to such a new world will open, which you and I cannot even imagine today. First of all, the entire pharma and medical industry will be revolutionized, because the process of making new medicines today is like finding a needle in a haystack of millions. We need to understand how the molecules of medicines interact with complex proteins in the body. We have to try possible combinations of billions of molecules to simulate complex chemical reactions at the atomic level in classical computers, creating three-dimensional models which are extremely resource intensive. Nature itself is quantum mechanical and works on quantum mechanical principles, like the photosynthesis process. If we manage to use quantum computers to decode the right drug combinations, then like today, making medicines would not be a matter of luck. There will be no need to spend billions of dollars and 20 years in the lab. These new drug discoveries could happen in just a few months. Pandemics, epidemics, and jinxes which have taken maximum lives historically, we can also finally say bye-bye to them, because any virus, be it pathogenic, we will be able to predict their possible deadly mutations at the molecular level by studying them and stopping them from spreading. In which case, these viruses will never be able to reach their tipping point. Even vaccine development or fighting strategies can be developed in a few weeks' time. Number three, and this development will be the craziest. Today, many diseases are caused by the malfunction of proteins in the body, such as cancers, which are affected by protein folding due to mutation. Parkinson's disease, Alzheimer's disease, and exactly these diseases, we do not have solutions today. This is because proteins are extremely complicated molecules. And to create their three-dimensional models, simulate every possible folding of them, then to interact new drugs with them in complex ecosystems, this is an extremely complicated and resource-intensive task. But quantum computers can do this work in weeks or months' time. So many diseases that we consider incurable today, we might find cures for them tomorrow. In fact, the human lifespan could extend to 100 or even 150 years, because we are now understanding our own biology at the deoxyribonucleic acid level and can optimize it with anti-aging drugs, supplements, lifestyle, and medical facilities. Just think about it. In the ancient ages, when science was not developed, a person on an average only lived for about 30 to 40 years. But today in developed countries, we are living up to 85 years. Increasing this life expectancy to 100 or 150 years is not as difficult as you might think. Number four, we will see the maximum benefit from quantum computers in the space industry. Doesn't space also work on quantum laws? And by modeling these laws, we can literally model complicated physics phenomena like black holes and quantum gravity accurately, which seems impossible for us to do today. We could even solve the mystery of dark energy and dark matter. Just imagine what secrets of the universe we could uncover. We could literally become the kings of our galaxy. Why? Because now we can very accurately predict the motions and positions of every single planet, star, asteroid, moon every second. Today, to make a single trip to Mars, we have to solve millions of variables. Quantum computers will make these calculations in fractions of time to keep the trajectory of the spacecraft correct. We can develop new materials which can revolutionize space technology and engineering by improving spacecraft and rocket design. And finally, the search for alien life will be potentially much easier because today distractions are stopping us from searching for alien life. Reduce distractions to detect technosignatures like radio frequencies or electromagnetic waves, in which we have to separate waves coming from the intelligent alien life from just interference or noise, which is an extremely complex task. The Search for Extraterrestrial Intelligence Breakthrough Listen project has been doing this for 20 years and still no success. Now, how does this alien search operation work? I have already made a detailed video on this, which you can also see by pressing the I button above. But quantum computers will do this work in a snap. Also, they can help in scanning large planetary data sets based on biosignatures and Drake's equations, focusing on those sets where alien life could actually exist. Number 5, new things in physics and mathematics will also unfold exponentially because complex math equations and quantum mechanics problems will find solutions in them, leading to the invention of new technologies, creating a domino effect of advancement. Number 6, artificial intelligence. Yes, artificial intelligence and quantum computers. They are two separated brothers who were meant to live with one another, because the exponential speed of quantum computers and the self-learning ability of artificial intelligence will infinitely accelerate the advancement of human civilization. And how the development of artificial intelligence will greatly improve the hardware and electronics of quantum computers, its concepts and ideas will speed up with the help of artificial intelligence. And maybe they both will continue to evolve together forever, and it would just never ever stop. What do you think? Today, when we talk about Kardashev Type 2, Type 3 civilizations, these advanced civilizations seem impossible to us. But all of a sudden, after unlocking quantum powers, don't they seem possible, right? But yes, we will have to remain skeptical because some of the most brilliant minds have already sensed the true powers of these. We have been cautioned to handle AI and quantum computers with great care.
My worst fears are that we cause significant harm to the world. If this technology goes wrong, it can go very wrong.
Artificial intelligence is one of the biggest threats.
So quantum computers have endless possibilities. These are some basic ones I told you. Till now, we don't fully understand their true applications. Literally, wherever our imagination can go, the application of these quantum computers can potentially go there. We just need a little bit of patience and creativity. And with that said, friends, our short series on the complete evolution journey of computers ends here. If you enjoyed it, you learned something new and are positive and excited about the future of humans, then definitely share this video with your friends and family members. Because we have to inculcate the same enthusiasm for science in India as developed countries. Thanks for watching. Glory to knowledge and India.